Just for the sake of practice, let's pretend we can just pick decimals up and move them wherever we want. So in this 48.3, if we're going to write it in scientific notation, we need to move it. It needs to be there. So it's no longer over here, we moved it. And for this one, we'd have to move it after the 3. And whoops, that's a 0. That's not a significant digit. We got to move the dot here. Same thing with this one. It has to be after the first significant digit. Those zeros are not considered significant digits, so we move the decimal. Again, I'm just pretending. We can't actually just throw decimals around. It would be kind of nice if we could argue that with a bank. I really had $100 in there. See, I just moved the decimal. No, it's not going to work. But in each of these cases, you have to put the decimal in the proper position for scientific notation. Whoa, this one's really got to go here. And so forth. Now these would be ready to multiply by a power of 10 and actually have them in scientific notation. So we talked about multiplying by powers of 10, and a lot of people forget what's up with the negative exponent here. Let's look at this logically. Let's look at the exponents on a base 10. We know that multiplying a number by 10 makes it bigger. If you have $5 and I say I'm going to multiply that by 10, you have $50. Well, let's look at this number, 5.35 times 10 to the second. Well, that's the same thing as saying 5.35 times 10 times 10. So, not just by 10, but multiplied by 10 times 10. So that's actually a jump of 2 decimal places. Here's one, 3.7589 times 10 to the third power. Well, that's going to be 3.75 times 10 times 10 times 10. So in that case, your decimal ends up getting pushed over 3 times by those 10s. So let's look at powers of 10 as decimal numbers. 10 to the fourth, then, is 10 times 10 times 10 times 10. That's 10,000. 10 to the third is 10 times 10 times 10, which is 1,000. 10 squared is 10 times 10, which is 100. But look at where the decimal's going. It's moving, isn't it? It's each place, each time we take off a power of 10, it's one place value smaller. And finally we get 10 to the 0, which is 1. Don't forget that. 10 to the 0 power is 1. That's an important point. Circle that in your mind right here. 10 to the 0 power is 1. But now look what happens when we have 10 to the negative 1. The same thing continues, the same pattern where the decimal is moving to the left, the number is getting smaller and smaller as we continue with now a larger negative. This is negative 2 now, and now that's, look at how that decimal pattern goes. So that should help you remember that a negative exponent is actually a very small number. Let's look. Well, 10 to the fourth we said was 10,000. We could write that as a fraction this way, and look at how the fractions get smaller. Here we're down to 10 over 1. Here's our 1 over 1. Now look, you get your negative exponent. It's actually 1/10. Negative 2 power is 1/100th, and so forth. Take a good look at that.